Hi guys, in this video I will tell out how Newton's law apply.
To find out what kind of magic this is, we'll have to go back in time. Okay, not that far. Stop. Yeah, that's perfect. This is Gravity Guy, but most people call him Isaac Newton. One important thing he said is that force equals mass times acceleration. Now, what do all these words even mean? Force is a push or pull on something in a certain direction. Mass tells you how much of something there is, and it's also a measure of inertia, but we'll get to that later. And acceleration is the derivative of velocity with respect to time, but that's too many big words for my taste, so let's just say it's how fast your velocity is changing. The key takeaway is that if you apply a force to a fixed mass, you get a predictable amount of acceleration. If you know all the forces acting on a basketball midair, you can predict with 100% certainty if the ball will go in the hoop or your neighbor's windshield. Whoa, did an apple just fall on my head? Yes, Newton, it did. Yeah, that must have happened for a reason, said Newton, as he discovered that two masses attract one another, making the apple fall. Yes, even you, no matter how ugly you think you are, attract pretty much the whole universe at least a little bit. Hey, can you put that on paper? Yup, said Newton, who gave us the law of universal gravitation. In other words, how much do bodies pull on each other given their mass and distance times a constant. Bigger mass, bigger pull. Bigger distance, smaller pull. Actually, a lot smaller pull. You see, as the distance increases, the force gets smaller by the square. That, my friends, is the inverse square law. Gravity is also the reason why planets in our solar system orbit the sun. They got their initial velocity when the solar system formed out of spinning gas, and since there's nothing in space to stop them from moving, they'll keep moving. Hey, that's Newton's first law. The sun is so massive that the force of gravity keeps pulling the planets towards the sun, but the planets are fast enough to essentially fall towards the sun but miss it, and this goes on forever, creating a round orbit. Actually, that's kind of a lie. Most orbits are not perfectly round, but more egg-shaped, and Pluto's orbit is just a complete mess, but you get the idea. In this case, the gravity is what we call a centripetal force. One thing many people confuse is mass and weight, and no, they're not the same. Mass tells you how much of this blob there is, and weight is the force of gravity the blob would feel. To make things clear, your mass would be the same on the Earth and on the Moon, but the weight you would perceive is different because the Moon has a weaker gravitational pull, meaning a weaker force acting on your mass. So really, you're not overweight, you're just on the wrong planet. Alright, enough about Newton, let's break some stuff. If you ever dropped your phone, it might look like this. What the hell, ground? Why'd you do that? The answer is energy. You know, the thing kids have after eating gummy bears. Energy has the unit joule, and it's not like force. It doesn't have a direction, it's just a number that's kinda chilling there as a property of a thing. You see, there's two main kinds of energy, kinetic energy and potential energy. In plain English, energy of movement and stored energy due to some circumstance. For example, when you held your phone, it stored gravitational potential energy due to being held above the ground at a certain height. Once you dropped it, that potential energy was converted into kinetic energy as the phone fell. Then it smashed into...
Guys, subscribe this channel and thumbs up and comments you if you want. Thanks for watching video.